You're on. Hello. It's good to be back, as always. Bit of a rush job today, but I made it. Had to run. Yeah, I had to run from Orange Channel to this one. And my apologies to the people on Orange Channel, but I do take my producing stuff a little bit seriously. So we had to forcefully end. There's no. It says you. Okay. Now you should be
Hello,
able.
can you guys hear me? How does it sound now?
It should
Have
be.
we been muted this whole time?
I thought I had hit. I thought I had hit the button, but apparently I didn't. So, my apologies.
Can you guys hear me?
Yeah, they should be able to hear you now.
Oh, yeah, it says okay. It says on there. Okay. Well, I guess you guys didn't hear me, but I said Happy Pride Month to everybody, which includes myself. So, fantastic. Awesome. Okay, great. Okay, and we have Peter, our favorite Peter, and we also have Nestlig, who is here with us today, one of my editors. Welcome back.
Hello. Good to be back.
Glad to have you. It is the three of we. Yes. Let's see. We got here in the side chat. Block Adelader.
No. Blokken
Jamie E.
Blokkadeleider.
Brian Stevens and Trudy Stubbs. Hello, welcome all. All are welcome. So
for
this
those,
week,
Jackson, for those who don't know, he's the leader of the blockade. That's what blokkadeleider means, Dutch.
Oh, is that what it means?
Yes.
What blockade is he running?
I have no clue. As long as he's not blockading our channel here.
That's fair.
People need to see that.
That's very fair. Yeah. Let's see. So this week we're gonna have Immutable Destiny on in a little bit, as soon as he gets home. So we can discuss maybe Abiogenesis stuff. Mm-hmm. Next week we're gonna have the one and the only Dapper Dinosaur on to discuss that absolutely bonkers claim that they made last week, that the video made last week, saying that there were penguins and parrots found amongst dinosaurs. We're going to talk about that next week and why that's just insane. Oh,
penguins and parrots. Oh my!
Mm-hmm. It was like penguins, parrots, flamingos, avocets, all that sort of stuff. Yeah, no, crazy.
Considering it's going to be about birds next week, it is only appropriate for me to have brought Easter eggs for the show today. I'm curious if people will notice.
Okay. All righty.
I did because I can.
I mean, that's true. I guess you can. Mm-hmm.
Yeah.
So I guess we're ready. Oh, the Kessel Run. Did he run the Kessel Run? Blockade later? The blockade he ran, the Kessel Run?
Probably not. You can't run very fast on clogs. He's Dutch. He's Dutch. Right? So apparently we all wear clogs according to the Americans. So yeah, you can't do a run.
The Dutch are taking over.
Yeah, you can't run very fast in those.
I guess it's just a matter of skill, right?
Well, we gave you New York, so
that's very true. Yes. It's very true.
We kept Harlem. I mean, it's still Dutch. And the Stuyvesant is also.
In fairness, you guys did also give us the Pilgrims, because they went to Holland. They left England, went to Holland briefly, and then basically got kicked out because they were so annoying, and then came to the New World. So,
are you saying the Dutch are smarter than the Americans?
I mean, well,
there was a compliment in there somewhere, picking out.
a compliment for yourselves,
Yeah.
perhaps. So let's see. Well, we are continuing onward with our favorite series of shorts,
Mhm.
shorts and t-shirts by Genesis Apologetics, the organization that claimed Mesonichids didn't exist, just categorically. Don't mind their fossils. Just don't worry about it. They're not real. We can also say this group now has claimed that penguins existed alongside the dinosaurs. Yeah. So it's been real fun.
And
What
so
was the other thing they said?
since I took the liberty to put in Easter eggs, I had to watch the entire thing again, and I noticed that a lot of those people are skipping class because
You're right.
you don't have two videos with the same people in the same spot, so they're skipping class, which
Yeah.
I'm considering the teachers might not be a bad thing.
I guess it's also like group taught because you have the guy and the woman who both like trade out, unless one of them is the substitute teacher, which could also be the case.
So I don't want to discriminate, but I think the female teacher might be the substitute teacher because she doesn't push back. At least the male teacher face palms and shows that he's not happy being there.
Right.
The female teacher, so much.
Yeah,
But
that's true. Except for the one Franco-looking kid, yeah, yeah, he was the only one who.
yeah,
That one kid who always talks. He's the one who shows up to every class.
yeah, I did uh put a restraint on myself because I felt the urge to put a dunce cap on him. I could have done that, but
Yeah.
that would just be
You know
petty.
what, Condor boss, I'm gonna mute you for being a pedant. How do you feel about that? You all know what I mean when I say the dinosaurs. We all know what we mean. Yeah, you and your pedantry. Anyways.
It happens. Okay, what shall we do? Shall we jump in and
I guess we'll jump in and then we'll just keep kind of occupying ourselves till Immutable gets here.
okay, let's jump in.
All right.
So you're saying that the 6 million year trail showing humans coming from apes and that evolution can fit into a pickup truck?
Yes, according to
Oh
the
my
emeritus
God, this
curator of the
again.
American Museum of Natural History.
And we're pushing 8 billion people right now and 500 primate species, and yet there's not a single transition piece between them? Nothing?
What?
I mean, I'm actually with Charles Darwin here when he says that if evolution was true, innumerable transitional forms must have existed. And then he questioned, why do we not find them embedded in countless numbers in the crust of the Earth? And then Darwin said that the lack of transitional forms is the most obvious and serious objection which can be urged against the theory of evolution. I think that we should seriously see more fossil evidence if evolution is true. And you think my position as a creationist requires faith?
Okay, so that was stupid. A whole lot of equivocation there. For one thing, first he said, "Oh, they can fit into the back of a pickup truck for like the 5th time." That has no bearing on. Oh, I do see it, Peter. We're on the TV. That's very funny. I like it.
Yeah, I thought you might like it. I hacked into the
I do.
school's Wi-Fi and
Yeah.
provided them with some better background.
Yeah. You know what, Brian Stevens, you're gonna go with him. I'm gonna mute both of you for being pedants. Yeah, I do like that. So again, the back of the pickup thing, back of the pickup truck, it doesn't matter. Like the fact that you can't fill up, I don't know, all the rooms in like the Empire State Building with 8 fossils doesn't mean anything, right? It just doesn't mean anything. There's no there is no expectation to have a particular number of fossils, right? Now, the fact of the matter is, there are literal mountains of fossils because that's what chalk is. Chalk, limestone, these sedimentary rocks, which are built from phytoplankton. These are literal mountains of fossils.
Coccolith.
Coccolith
be
floors, yeah, that's
specific.
another one. Yeah. Yeah, these these things are bigger than like, any structure we've ever created, right? You go to the White Cliffs of Dover. Those are fossils. Those are forams and diatoms and coccoliths and radiolarians that just make up the rock. And you can find transitional forms between them as you go up the layers. You can see how the species in one layer transition to the species in the next layer, and the next one, and the next one. For hominins, we do have fewer because obviously vertebrate populations are much smaller than invertebrate populations, just as a result of their life history. But we do have a bunch of hominin fossils. We talked about a bunch of them earlier. We talked about Homo erectus and archaic Homo sapiens. We talked about Homo habilis and the Australopiths and Auroran, Ardipithecus, Sahelanthropus. These are all transitional fossils that are in the the hominin lineage. And if you want to go back further than that, there are other there are like basal apes, right? So you have like, what is it, the Dryopithecines, and you have proconsul, and you have in like the early orangutans, you have like the Civipithecines. There are what else? You have like what is it called? Oligopithecus, which is a like ape-like monkey sort of guy. Then you have like Victoriapithecus, which is probably sort of the ancestor of all the old world monkeys, the catarrhines. So Victoriapithecus kind of lived like around the time that we expect their common ancestor lived. Then just going back and back and back, and so there are lots and lots of transitional primates. We've done a bunch of videos in the Ancestors Tales series in which we talked about different transitional primates, going back to like the strepsirrhines. We have like Darwinius, which is like a basally derived strepsirrhine. So there are transitional forms like all the way down. And then of course also outside of the primates there are extremely basal like primatomorphs like Purgatorius, and the Plesiadapiforms, these things which are not crown primates but they're stem primates, right? So they're super duper primitive. So
Plesiadapiforms?
Yeah.
Oh yeah. Yeah, those I think those are stem primates, but I was first thinking about you were referring to the Adapiforms, and the Adapiforms are I think closer to the strepsirrhines, right?
Yeah, I think you're right. On that. Yeah, and then there's the Omamaiaforms, which are also like basal haplorhines, I think.
Yeah.
So there's lots and lots and lots of different fossil primates. So the idea that just because we can fit all the human fossils into the back of a pickup truck, that means we have no transitional fossils. That's just insane. That's a complete non sequitur. So yeah, no, just bonkers.
Who's your buddy? Who's your buddy? Yeah, but where does Piltdown Man fit into your little tree, Mr. Scientist?
He fits in the dumpster.
But I did have a rebuttal to this particular question, because they can complain that there aren't enough fossils. Please, can you show me fossils of the Nephilim, fossils of the giants, or maybe
Peter, the Smithsonian is hiding them.
This is the best one. Can you provide me fossils of God's original created kinds? Every single one of them, please. This is what we've been waiting for. This would be a breakthrough for intelligent design and creationism both, if we had those fossils. And then if you can find some fossils of angels and demons, those would be good. I mean, snakes that still had legs, both front and back.
Well, we have one of those.
We have
Um,
we have one with remnants, which
Yeah.
they couldn't walk on. I want to see a snake with legs that could actually walk.
I think they just call those lizards.
Don't spoil it, Jackson. I mean, why do you do this? I mean,
I don't know. Product of my upbringing, I guess.
and I want to see a snake fossil that has vocal cords. That would be a good one.
I don't
Because-
know. Yeah, it would be nice if we had the fossils of the created kinds. I know creationists like to say the things buried in what is it? Is it like Precambrian is like the creation week stuff, and then up to like, well, I guess they kind of argue that whether it's like the KPG extinction or like later, that's the like the flood boundary. Then everything else after that is more recent.
I have no idea where they draw the lines there.
Well, they disagree amongst themselves because there's no there's no way to really figure it out
It's
because
like,
it's all crazy. So.
all right, Mesozoic, Friday, Cenozoic, Saturday.
Yeah, because it's absolutely insane. So I don't know.
I mean,
right. Well,
the fact that they disagree 9 out of 10 times means that you have a transitional fossil, because one would say it's 100% this, and the other creationist will say no, it's 100% that. So they will be fighting over that. So that's a sure sign of a transitional fossil.
Yeah, that's true.
Okay.
All right, ready to keep going?
I can keep going.
What did you just say disproves evolution?
Mice, lizards, and finches, of course.
Well, I'm not sure what you mean. Evolution is
What?
driven by nature selecting the fittest creatures to survive and reproduce, passing on their favorable traits while the others die out.
Well, how's that happen, Professor?
Well, mutations and natural selection.
But research is now showing that creatures are pre-programmed to adapt to their environments in just a few generations. You see, their survivability is not just dependent on random chance, but it's because they're created to do so. And here's where the finches come in, okay? Darwin believed that different shapes and sizes of finch feet and beaks, depending on their different islands, was showing evolution, right? But this is where epigenetics comes in, okay?
No.
So, mice, they can grow different
We already
vertebrae
went
depending
over
on if
this.
they're in the forest or in the prairie.
Oh,
Lizards
no,
can grow
not
longer
this
legs
one.
depending on their location. You see, this isn't just some random act of chance. This is pre-programmed epigenetics.
Okay, so I know exactly what he's referencing. So this is what he's referring to is called continuous environmental tracking, which is what the ICR pushes now. Randy Galuza over at the ICR. This is kind of his bugbear. It's bogus. It's totally bogus. It's absolute nonsense, and it was debunked 80 years ago by what's called the Luria-Delbruck experiment. So the Luria-Delbruck experiment took, I think it was E. coli, and they subjected E. coli to phages. And so some populations, let me back up for a second. So what they were testing was, does the environment cause mutations, or do mutations happen and the environment simply selects them? That's what they were testing. So if the environment caused the mutations to happen, then you would expect that 100% of the E. coli populations would develop resistance to the phages, right? Because they're all subjected to the same selective pressure. So they should all develop the same, or well, they should all develop mutations for the same phenotype, right? Which is resistance to the phages. But what the Luria-Delbruck experiment showed was no, not 100% of the populations developed it. Only ones which had particular mutations which conferred resistance to the phages were the ones that survived. So the environment did not cause the changes. The changes were present in the bacteria, and then they were selected by environmental factors. So that was in the 40s. That was 80 years ago.
Yeah.
That this idea was disproved.
Yeah, and I also know of another experiment. It's called the Leaderberg experiment, like in the 50s, I think, in the 50s. What they did was they spread out bacteria on a plate, and they allowed to grow them into like different colonies on the plate, and then just reading I think Berkeley has a good page on that, Berkeley edu.
Mhm.
And it says that these colonies were stamped with an antibiotic. It contains an antibiotic, penicillin,
Mhm.
and so some of the colonies survived, but not others.
Right.
And what it was that in the plate without antibiotics, the same mutation or similar mutation that conferred resistance happened on the same frequency as the mutations that happened on the ones with penicillin. So the presence of penicillin did not increase the rate of the mutation. It just selects them.
Yep, exactly. So this idea that the environment causes changes, like genetic changes, is bogus. So they try to deflect with. So one, Randy Galuza just lies about it. The thing about the mice, about there being like field mice versus forest mice, that's like, it's just a lie, right? With by saying, okay, well, if you raise the mice in the forest, then they have more vertebrae in their tails because this helps stabilize them as they like run across tree branches. But if you raise them in a field, then they just don't develop as many vertebrae. That's just a lie, right? What he's referring to is these are actually two different, I think they're, well, like subspecies of the same, of like Paramiscus or something like that. But they're within the same species. It is not a matter of just raising them in different places and that just affects how many vertebrae they have. No, that's not how that works. He mentioned the finches. We debunked that last time where we talked about the finch beak gene. So it is genetic changes that cause differences in finch beaks, not epigenetic changes, though there are epigenetic changes involved, certainly.
Yeah.
But there is a gene that is predominantly involved. And again, there are epigenetic changes there are epigenetic factors involved in mouse development, involved in the development of all animals, right?
Yeah, the developmental biology is mostly epigenetics because the genes mostly are the same between all cells in embryonic development. What matters is that some genes get shut down in some cell lines.
Right.
And that is remember. I think like one example that it's a good video by Veritasium, where he mentioned how like in people with the two X chromosomes, one of the X chromosome gets shut down, and it's actually when the shutdown happens at a certain stage when you have multiple cells. So in some cells, like half, one of the X chromosome is shut down, and in the other half, the other is shut down. Mm-hmm. And sometimes you can, like in some animals, for example, the calico cats, I think, or the how do you call it? The certain cat.
The calico cats.
I think so. Or maybe like the ones with many different colors.
Yeah,
basically.
calico.
Yes, and in those colors are caused because in some cells, one of the X chromosomes got shut down, and in others the other got shut down, and so that's why you have these different colors in the female cats with the two X chromosomes.
Right. Yeah. It's just the Trudy Stubbs points out, wouldn't continuous environmental tracking basically be Lamarckian? Yeah, it basically is.
It's fun. It's funny that they are so, they're now at this point so against Darwin that they even deny natural selection. Like they used to say, oh, okay, natural selection, all right, but now they are going completely against it, and they are full Lamarckian almost. Yeah.
Right. And the kid did ask one question, or guy, whatever, because he's probably older than me. The guy sitting there on the front did ask a decent question, which is, well, how exactly does natural selection work? Well, natural selection refers to differential reproductive success. So individuals in a population are all slightly different from each other. Even, bacteria, which are supposed to be all identical, they may have very slight differences from each other as a result of copying infidelity, which just happens. I think tautomerization is like the most common type of point mutation. Basically,
what is it? Cytosine to thymine or something like that?
Yeah, stuff like that. Where you basically the polymerase mistakes one base pair for a different one, and so it adds the wrong one. And so stuff like that. It just happens because these are enzymes. They're not perfect. They're doing the best they can, but they're not perfect.
Chemistry of sloppy.
Right, exactly. And so
Also, hello, Immutable. Welcome here.
Well,
Cool.
thanks. Glad I can get involved.
yeah, we're gonna skip back to the Abiogenesis ones in a moment. But yeah, so these variations confer slightly different fitness effects. So basically, the individuals have different numbers of offspring depending on how their mutations allow them to survive in the environment. Maybe these variations make them better or worse at foraging for food or wooing mates or what have you, evading predators. And so the ones that have what we call beneficial variations are the ones whose variations are on average more likely to allow them to survive and produce more offspring than individuals with other variations. And so that's all natural selection is. Pretty simple.
And it's also, we should also bear in mind like the fallacy of monocausism, as you would like to say. Like, of course, they often put the dichotomy between it's either random mutation and natural selection, or it's all programmed mutation. And no, it's probably I'm not aware of any pre-programmed mutation. Maybe the best examples are like the immune system, like how you have like in a specific locus, you have like hypermutations that cause our different antibodies. But even that is still a random process. It has to be filtered out, because otherwise you get the autoimmune disease if it doesn't work out right. Yeah. But still, it's probably there may be examples of where you can have like epigenetic responses to the environment and still be involved. But it doesn't override the importance of the random mutations in genes and such. Yeah.
Yeah.
All right. Sorry, Immutable. You wanted to say something.
So to kind of like push back slightly on that, I mean, I think I think probably the best creationists can do at this point is to kind of push back on the notion of natural selection by just kind of like trying to make an argument that it's like somewhat tautological in nature.
Oh, like what Jerry Fodor does?
Mechanism, which I mean, I kind of get.
Is that what Fodor does?
Just to say like. But I mean, it's. I think if you're not careful with how you frame natural selection and just saying like, the organisms which are most fit to survive do survive. Well, sure.
Isn't that why we define it as
that itself?
That's so clear. Yeah.
Sure, the most fit survive because they're the most fit. Right. Yeah.
But that wasn't the objection they made here. They made the objection that mutations are not random. It's all pure destiny, basically. It's everything is pure destiny or programming basically, to an response.
No, I know. I'm just saying like that's an objection they could. Like a more sophisticated objection they could raise towards like natural selection.
That's why you have to say is it's like it's like an average, right? It's about the statistics of which are more likely to survive on average given a certain set of variations, which is a lot more wordy, but it also
given a certain environment is probably the way I would kind of like quantify it.
Yeah, given a certain environment with a certain set of mutations, these organisms are on average more likely to survive than their counterparts, I mean, it's certainly more wordy, but you could do it that way. But yeah, you're right.
Yeah, I mean, the other thing with like this idea of kind of like in continuous environmental tracking, kind of like the model they're putting forth here, it's kind of like you run into a really weird and interesting kind of issue of like if that's actually true. I mean, it's not, because you can construct experiments, and experiments were constructed in like the 1950s to disprove it.
Yeah, we talked about the Luria-Delbruck. I don't know if you were. Okay.
But I mean, it's like if it were true, like just granting the hypothetical temporarily, it's like what exactly, like, so certain populations that like really don't survive, like you give a like population of E. coli like a very strong like like bacterial resistant, and you have like, I don't know, maybe 10 bacteria that survive or something like that. Why, like, what is it that promotes like certain bacteria or like certain populations to like have that potential, right, to adapt in the way you're proposing, but like the majority not? Because if that notion were true, like if organisms could sense their environment, right, and make the program change to like adapt as needed, it seems at best that it's very sloppy, right? Like it seems at best like that it's a very bad mechanism, like just given like the way in which you can test for like resistance of like a colony of bacteria versus something known to like eradicate the majority of them.
Yeah, I think they don't really think it through. It's it's what RJ likes to call the gee whiz argument, which
I
is
think
oh wow, it's so cool that these organisms can do this, therefore God. And
well,
that's
it's
kind of what a lot of it boils down to.
I think first and foremost, it's just a reactionary argument in the sense that like, and you see this a lot with creationists, like in the case of like human evolution, they initially say we don't have ape men, but what happens when we do finally have transitional forms that are like innumerable? They just right. Well,
kilograms.
Yeah, well, it's just like, oh, well, they don't say, oh, we don't have any complete specimen. Like they make the claim different. So they don't, like, in my opinion, they don't really have kind of like a long-term view in mind. They're kind of just like trying to make points that they think are valid in the moment, and not really considering like ramifications of if the predictions are fulfilled.
Oh no, you're absolutely correct. I mean, creationism is an exercise in putting out fires. That's all it is, right?
Oh, yeah.
Because the science moves forward, and they're just like, don't worry about that. Don't look at that. Don't perceive that.
Or they just resort to
an exercise. It's an exercise in putting out a huge firestorm. Right. So that's what it is.
Well, and the other thing is too, like they've played the cautious game by learning from Douglas Axe that you don't make predictions with creationism.
Correct.
Because the time you do make predictions and people like actually test them or show data that like directly contradicts it, it's like, oh, you guys look like absolute fools. It's like, well, you guys are just biased on your own, and you guys are using assumptions too.
Well, you've seen the Jason Lyle saying like the speed of light is like infinite in both directions, or at least in one direction.
In one direction,
and it like screws everything else up, right?
I mean, it's like there's nothing theoretically wrong with proposing such a thing, but it's kind of like this point of like, to use a similar analogy, of when creationists say like, oh, God sped up the speed of light like by just like a billionfold, like moments after the Big Bang, to look everything, look like it's the case. But it's like, if that's the case, right, there's a very fundamental relationship that the speed of light has to the strength of electric and magnetic fields, right? It's like, well, if that were the case, though, you wouldn't have the structures we have now, right? The way in which those structures exist, be it their chemistry and planetary physics that let them stay, as they are in this kind of semi-stable state, they would collapse because you're just accelerating.
Every star would explode because E equals mc squared, right? If you increase the constant of light, speed of light, and you also increase the amount of energy that stars release by many orders of magnitude, and then the whole universe goes up in flames.
Yeah, like, okay, fine, you've avoided the issue, but you've obliterated everything else like that exists. It's like, congratulations.
Yeah. Or the heat problem. That's another one.
Jackson, you have to be correct, because not all creationists are putting out the fires. I mean, at least half of them are very engaged in moving goalposts, because that's another issue.
I mean,
they bitch about the incomplete fossils of humanoids, whereas they accept dinosaurs for which we have incomplete fossils. Apparently, that's just fine.
Not transitional dinosaurs, though.
No, but they have to accept the dinosaurs because they were on Ken Ham's boat. I mean, have to be.
Yeah.
And otherwise, if they don't, both Ken Ham and Kent Hovind are out of a job, because then we wouldn't have dinosaurs. If they can't be consistent.
To the
yeah, go ahead.
Just to jab at like one thing Peter said, it's like, it's not that creationists like aren't always focused on moving goalposts. It's that they're getting more elaborate with how they can move goalposts. Because it's all they really can do. Like, unfortunately, like, even to use kind of like modern examples of kind of like more sophisticated creationists with Sal, it's like, yeah, can you guys you guys can make arguments, but you have to do it based upon like misrepresentation of data,
Yeah.
right? And it's not like, oh, we just disagree philosophically. No, like I can read the paper and I can tell that what you're saying about it is quote mined. It's like deliberately not agreeing
So
and not even representing properly.
I don't know if you guys have seen Erica over at Guts and Gibbon. She just put out a video on Jeffrey Tompkins.
Yep.
So she's saying one thing I thought was really funny that she was saying the other day was the creationist responses to her video have just been, well, we have different philosophies, different philosophical assumptions. And she's like, no, I literally tested his methods. You can't just say that. You know?
Yeah, I mean, I think in this case, like even if me and the creationists disagree, I could kind of give them certain points with that, right? But in this case, like it's not wrong on a scientific basis; it's wrong for math reasons.
Right.
Right.
Yeah.
It's wrong on the basis that like the way you're computing it is just like an extremely elementary error.
Yeah.
So like even if you were to grant like that the methods he was using like were perfectly legit, it still doesn't follow because the weighting and things like that are just fucked.
Yeah. So well, since you're here, are we ready to do the first Abiogenesis video?
Let's do it.
Peter,
Deep
I can't
sigh.
hear you.
Right.
You're muted.
We have to go through this the way it is because otherwise I'm never going to get the place back where we now skipped off. We have minute 49 left. So and then we'll get to the start.
Oh, we can.
Yeah, because for me it's
we can ram through the last video. Yeah.
For me it's it's one video. So
that's fine. Okay. Yeah.
Okay.
That's good.
Okay.
All right.
So here's what they were doing in 1909.
Those hats are fire.
Up here, please. Yes, the picture from 1909 I was trying to show is this one.
No.
For years, scientists have portrayed Neanderthals as gorilla-like cavemen, kind of like a last step between ape-like creatures and humans. But nowadays, they probably looked more like this.
Hey, cute man do.
Why are they still being used as evidence for ape-like creatures turning into humans? I mean, they seem much more advanced than many ancient people groups.
They're not used.
Don't we all know somebody with those well-defined deep eyebrows? Right? I mean, they also had jewelry. They had musical instruments, weaponry, medicine, artwork.
We definitely don't know
Scientists
that.
are still trying to replicate a type of glue they used for their weaponry.
I even heard that the Neanderthals lived with, had families with, and were buried with modern humans. So to me, that settles it. I think they're just humans.
It sure does.
Okay, so
wow.
First of all, we don't know the medicine thing. I haven't even heard that one, but I don't know of any evidence for that. The music thing.
Were they responsible for some cave art? I don't know about that. If they
cave
were
art,
responsible for
I
cave
really
art.
wouldn't be surprised. But yeah, I don't know. But the music thing, we don't know that they had music. That's how does that fossilize? They had kids
the radios,
with,
Jackson.
Yeah, we do know
the
they
radios.
had the radios. Yeah.
Yes.
Yeah.
We do know that they were mating to some extent with modern humans. There have been, of course, all people of Eurasian descent have at least. Probably most humans on the planet now have some Neanderthal DNA due to admixture. But
yeah, it's like a clinal variation from Europe to the rest of the world. Like in Europe, there is more a high degree of it.
Right. Yeah, it's probably pretty much everybody has Neanderthal DNA now.
Yeah.
I don't know about being buried with humans. I haven't heard that. Maybe. But yeah, they found a Neanderthal flute. Yeah, the thing is though, humans and Neanderthals overlapped in their tool industries. So how much of it is human tools? How much of it is Neanderthal? And how much is how much is them trading between each other or taking from each other? And how would we differentiate? I'm not entirely sure. But at the very least, there does seem to be overlap between Neanderthals and humans in terms of their tools. What'd you say, Peter?
Yeah. I think there was at least one family found a Neanderthal man with a human woman.
Yeah,
Okay.
yeah.
child.
Yeah, I
I'm
recall
not
hearing
entirely
about
sure.
that too.
But yeah, we definitely know that they interbred, right?
Yeah.
Same with the Denisovans. We know that humans, Neanderthals, and Denisovans all interbred with each other. So, but they definitely were not just humans. They were not just modern humans. We have their mitochondrial and nuclear genomes, and they fall outside of our known human range. So no.
Yeah, it's they are like our brothers or sisters or both. Yeah, but they are not within the same variation that we have today within our own population. Basically, they are not within that. They are a separate group, but still closely related to us, and we could interpret. But they are still a different group. I mean, like for example, the brown bears and the polar bears. Basically, they can also interbreed, but they are separate populations that have diverged from each other.
But also, like, they're not being used as evidence that we evolved from other apes, right?
Yeah.
That there are
might have been an
sister
early,
species, you know.
Yeah, that might have been a very early idea that Neanderthals were the ancestors, but that's not been an idea proposed for a very long time. Again, severely outdated.
Oh no, the creationists using outdated data. Who would have thunk it?
Oh,
they're only late.
But they weren't
they're
they
only late
just
to research by
humans
like
with
50 years.
They're just humans with rickets or whatever they had.
Well, yeah, there were some ideas that like the earliest fossils that were found were like maybe like soldiers from Napoleon's army or just a guy with rickets, or you know, there were a few other things like that they were thought, and then it turned out, well, no, they've got some morphological characters that distinguish them, and then
we also have Neanderthal children too. So yeah,
and we know that they took care of the injured because I remember Trey the Explainer did a video way back talking about like there was a Neanderthal with like healed broken bones, so they took care of their wounded.
Also, a question: is it Neanderthal or Neanderthal?
I've always pronounced it Neanderthal because it's
German.
It's Neander Valley.
It's
Neanderthal.
It's close. It's between Frankfurt and Heidelberg.
Yeah. The H is in there, but I've always pronounced it Neanderthal.
Yeah, as the th as a th is more English. It's more English pronunciation.
The German.
I would make a big fuss. I would make a big fuss about anybody mispronouncing it. So just curious. Yeah.
Yeah. No, I mean I mispronounce stuff all the time. Most of a lot of these words I just read them and then I assume a pronunciation. So like what was it? Tinnimus? I don't know how to pronounce that.
Tinnimus. Yeah.
Tinnimus. I don't know.
What?
Tinnimus. Tinnimus.
Tinnimus. The Canadian pronunciation.
The Tinnimus. 1 Tinnamu, 3 Tinnimus. No. Anyways. Anything else you guys want to add on this?
I did make a meme once for a follower from Louisiana, by the way. And he said, if you speak 2 languages, you're bilingual. If you speak 1 language, you're American.
I'm pretty sure I say that.
Yeah, that's something I've heard before.
Okay, want to continue?
I'm pretty sure I say that regularly. Yes,
you have.
Yeah.
All right, yeah, we can keep going.
Evolution isn't true.
Says who?
Your mom.
What?
Well, mitochondrial DNA is passed on from our moms. And while evolutionists say that human evolution started about 100,000 years ago, some controversial mitochondrial DNA says that it may have started much more recently.
Well, they showed that the observed DNA mutation rates actually point back to the first woman about 6,500 years ago.
Well, the Science Journal is also saying that evolutionists are more concerned with a faster mutation rate, probably because it contradicts human evolution.
Well, these discoveries have even contributed to the development of new research guidelines used by the FBI in forensic investigations. But I'd say it's mere coincidence that these ages coincide with the Bible.
Or is it?
So what they're referring to is Jensen's stupid argument where he conflates the mutation rate with the substitution rate.
Right.
And The funny thing is, Dan Stern Cardinal over at Creation Myths and some other people called him out for this like a while way back, and Jensen's. Let me not just refer to everyone with pronouns. Jensen's followers defended Jensen, like standing for truth, by saying, no, Jensen isn't just using the mutation rate. And then Jensen went on a chat with Dan and said, yes, I'm using the mutation rate instead of
So
the
what?
mutation rate. Yeah, right. So what? It's like, what are you going to do about it? Which is amazing. It's like, you can't do that. Everyone knows you can't do that.
When your dumb followers are smarter than you.
Yeah. I love that they all try to defend him and be like, no, he's not doing that. He's totally not doing that. And he's like, yeah, I'm doing it.
I thought they were also referring to the fact like that in certain, like there's a certain segment of mitochondrial DNA like that's known to like very often like mutate quite a bit, and that it's not very like
COX, I think.
Yeah, and it's not very reliable if you're trying to base like molecular clocks off of it. Just because like the mutation rate can be very, very variable, and so like if you use that segment, you're going to get like a time frame that's potentially like much shorter than using portions of the mitochondrial genome that are more stable to actually base off that kind of analysis. So I mean, I thought that's what they were referring to, but I mean, it wouldn't surprise me.
That might be there. I mean, in fairness, their arguments are so vague that they could potentially be referring to a lot of things. So
and that's
definitely
like,
possible.
I don't know if that's intentional or if it's just like if they intend to put out more videos kind of like in depth of like why they think certain things are incorrect. I mean, they have like the John and Jane series and the train wreck that was, but like we'll see. I mean, Genesis Apologetics is kind of like seemed to kind of like, I don't know, like kind of dwell down on their activity like with science related reasoning in the past years, but I don't know.
$1.99 from Trudy Stubbs says, gotta go, but have a great stream. Thank you from Trudy. Thank you very much. Appreciate it. Yeah, Genesis Apologetics they're just kind of troll for everything, right? Like we mentioned earlier, they did a video where they said that the fossil group called Mesonicids, they just didn't exist. They said that in one of their videos, which is insane. Like, you know, here you go. Here's the skeleton right here. Right? And they're like, what do you mean?
Are there? Okay, I'm just like curious now. Are there like a lot of predominant creationists? Well, are there predominant creationists like working for ICR or for, not ICR?
Genesis Apologetics.
Yeah,
I don't actually know who's over there. I don't know if it's like they get assistance from the bigger groups, but they're their own thing. I'm not really sure.
Yeah, I'm curious about that because like I know that with the we talked about the Abio thing or not long story made short or something like that.
Yeah, long story short, yeah.
Yeah, like he seems to be kind of like a subsidiary or kind of like sister channel of the Discovery Institute.
Yeah.
So I don't know if like it's that kind of thing of like they're, you know,
it may
part
be
of like
I'm
a bigger ministry or what exactly is going on.
Yeah.
Because the two biggest ones still, as far as my knowledge is concerned, is like between ICR and AIG.
Genesis Apologetics does use a lot of imagery from Answers in Genesis. They might.
Yeah, they may be a subsidiary channel of them. That's possible.
Because I mean, it seems kind of like with the way their channel is branded that kind of would be consistent, like with what they're trying to go through.
Yeah,
I don't recall like Answers in Genesis. I don't know if their view of like the flood model kind of like reflects the same view that AIG holds or not. That would probably give it away.
I don't think that Ken Ham is the type to share money. So if
that's true,
no, but it's also the fact that like I think Ken Ham or the people kind of like running the like social outreach program are smart enough to kind of like utilize different outlets.
It might
my
be
only counter argument to them being AIG is they used continuous environmental tracking. That is exclusively ICR. Nobody else buys into CET except ICR. That's like Randy Galuza, who's the head honcho over there. That's like his specific thing. Yeah, nobody else uses that. So I don't. That's why I say like if they are associated with AIG, it would be weird that they'd be using that because AIG is totally fine with natural selection. But yeah, ICR is like digging in their heels and saying no, natural selection is not real. But they're kind of the only ones. CMI is also fine with natural selection. So it could just be another organization who draws on all these different guys. They're like smorgasborders, basically.
Maybe.
Yeah.
And it'd kind of be interesting to see that because, like, I know that one creationist area, Debunked TV is the channel name that it uses.
Okay.
It's like it's an offshoot of like Living Water Ministries, right? So like
Comfort?
the same, yeah.
Mhm.
And I mean, unfortunately, like the arguments that their people give, like Bub and Bob or whatever the hell, it's like very, very obvious, like that the arguments are just like low tier with respect to like arguments that can be made with creationists.
Are they like they do the you see a Coke can? It's perfectly designed by God.
Mm-hmm.
Oh no! Like if you guys want to, like I can show you one of their videos where they go through, like they're trying to debunk evolution, and like the way they try to do it is like mathematically, and it's just like it's hilarious.
Maybe we could.
It's hilarious to see them like stumble with it and just
we
like.
Might. What would you say it's called? Debunk videos? I might try.
Debunked. So it's capital DE. Capital BUNKED TV.
Debunked TV.
Yeah.
We might try that in the future, maybe for some of our videos. I don't know.
Yeah. So like, it's interesting because they have they have shorts, which is this very like I don't know PragerU-esque narrator.
Okay.
Like that kind of gives this like anywhere from 3 to 5 minute video regarding why they think the thing they're talking about is incorrect.
Okay.
And it's like spitball nonstop, just like claims that are almost certainly wrong.
Okay. Yeah, we could definitely do some of these in a future video. That'd be fine. Okay.
Yeah,
that's a good idea.
It's one of the more interesting ones. More interesting in the sense that it's like not. I don't know if it's like entirely more known about. The only reason I know about it is because Erica, on in her video like regarding the L+ ratio for Twitter creationists, mentioned mentioned and reviewed part of one of their videos, which was trying to address why the fossil evidence in their view doesn't prove evolution, which you can imagine how that went.
I think I found that when the fossil record proves evolution from a year
Debunked.
ago. Yeah, debunked. Yeah, okay. Yeah, these might be fun to go through.
Oh yeah, I mean it's they have like a short form of it in the sense, and they're short section, but they also have like the longer version where the two people like Bob and Bub go through and explain like why they think the short is like good and try to give biblical defense for the whatever topic it is.
Okay. All right. Well,
it's bad. It's bad.
All right. Yeah, I'll definitely have to check these out. That'd probably be a good topic. Yeah. Okay.
Yeah, I mulled through one of their videos out of like morbid curiosity, and I was just like, wow, okay, yikes, this is I mean, you thought Standing for Truth had like wild and bad arguments, but geez.
All right. We ready to keep going?
Sure.
All right. Yeah. Let's keep going so we can get to the Zabio ones. Oh, they even use a SpongeBob in one. Of course they do.
Let's see if this works.
All right.
Christianity is a blind faith, but belief in evolution relies solely on science.
Hey, that's right. Living things can't come from non-living things.
Huh?
Like the professor said, right? So evolutionists have to believe that non-living matter became alive at some point in time down the line. Professor, can you give me a non-disputed scientific fact of how that could happen?
There are several theories, but science is still trying to figure that one out.
Right. So the law of biogenesis states that life can only come from life. It is scientifically impossible for life to generate by itself. But that is exactly what you believe, sir. And that is the definition of blind faith.
Okay, so pause.
Mhm.
I don't know. I don't know, and I've seen other people kind of address this too. I don't know if when they're referring to the law of biogenesis, if they're actually referring to the law of biogenesis, or if they're referring to like the biogenetic law, and in which case both of them are false. So, like the law of biogenesis is just stating that like we see like that life gives that like current life is given form like by pre-existing life, and it says nothing about where
a
that
new
life came
generation
from.
doesn't spontaneously appear. It comes from previous generations. Yeah.
Right. That's all the law of biogenesis is trying to get at. And the biogenetic law, right, is false as well, because like it's wrong for the reason that like if you consider something like a diseased or a cancerous cell, right? Well, clearly it's the case that not all cells, like when a human is born or whatever is born, are born in that state, right? There's mechanisms that give rise to different kinds of cancers or different kinds of diseases that afflict cells. So, like, it's not true necessarily, right? That like that those kinds of life always pre-exist. It's a fair point to say that like, yes, abiogenesis has to occur, but that's true independent of evolution, right? Even creationists have to accept abiogenesis in some capacity, right? They're just going to say God did it in some elaborate, sophisticated way, which is fine, right? But so the process of abiogenesis and the existence of pathways that may lead to life are agnostic regarding evolution.
I do want to point out, Smitty said in the chat, pretty sure Louis Pasteur didn't say that primitive cells can't develop from advanced organic chemistry. You are correct. In fact, Pasteur did believe that living organisms could arise through a series of that like very primitive cells could arise through chemical pathways. Not that you would get modern organisms, but that in fact cells could do that through abiogenesis. And he even tried to get cells to do that. And there are letters that he like exchanged with his wife in which he tried to do that. So when creationists when creationists say that Pasteur disproved abiogenesis, no, he never tried, but also he believed abiogenesis could happen even after disproving spontaneous generation. So, all right, what did you say?
And also the idea that Pasteur did disprove was the idea of spontaneous generation. Like it's often confused with abiogenesis, but spontaneous generation does not say life comes from non-life. It says that you have a newly living thing coming from a thing that was once living and is now decaying, and through the process of decay, it's the life force like spills out or something, and that causes a new life form to emerge. So it doesn't say life from non-life. It basically says, oh, life that is in the process of dying can produce new life, which is not true either. Yeah.
Yep.
That's the idea that was disproven.
Yeah, I mean, I think maybe one more. Actually, I'll wait till the second video because it'll apply to that as well.
Okay, all right.
Well, I don't recall who it was. Maybe you can help, Jackson. There was this guy who had a jar of peanut butter and disproved evolution abiogenesis.
I don't remember his name.
By opening the lid and saying, "See, there's no other animals in here. I had opened this a week ago and still no new animals coming out of it. So abiogenesis."
I think I know who you might be talking about.
I don't remember what his
Edgar
name
Pastrado?
was, but he was in. I don't know if that was his name, but well, he was in the video. He was in that video. That came out way back.
It was a long time ago. Very old.
What was? Yeah, I can't remember what his name is, but yeah, he was like, I had the jar of peanut butter and I opened it and see nothing jumped out.
Yeah.
Is it the same guy that did the experiment?
No, it's a different guy.
No, this
Okay,
this
not
as
Edgar.
far as
You're thinking
as far as
of
I
Edgar.
can recall, this
That
this
wasn't
was a TV host for some TV show,
Oh, I think I know who you're talking
and
about. In that
he stole
case.
the idea from someone else, someone who came up with it. But the video clip of the TV host is what went viral, at least what 5-6 years ago. A lot of creationists
it's
were
been a
showing
while.
that.
But I do remember, yeah. I think that was the same video where the guy said, "If the Bible said 2 + 2 = 5, I wouldn't question it. I would try to."
Yeah, but that
understand
was
it."
that was a different guy. That was a different guy.
That was a different guy.
Yeah, that was.
No, I mean, that was the same video, wasn't it?
Uh,
Or was that a different
I
video?
see Chuck Missler.
Was that him?
I got there's one name that pops up on Google.
Oh yeah, fish head salad said Meisler or Meisler. Yeah,
It could be.
Beats the hell out of me. I don't know.
It could be.
but yeah, I think you're right. I think that's who it was. Anyway, all right, you ready?
It was a video that was used in several creationist videos at the time. It popped up pretty much everywhere. Everyone showed that particular clip to debunk abiogenesis. Stupid.
Yeah.
Okay.
Yeah, it's Chuck Missler. Yeah.
Yeah. Okay. This is our last one, Jackson. So.
Woo! We did it. All right, let's do it.
Let's go.
Yeah.
It says here, our traits are passed down according to our genetic code, according to a very specific set of rules first observed by Gregor Mendel. And in my opinion, that's a huge blow to evolution.
Okay, I can't wait to
All
hear
right.
this.
Genetics is a blow to
first,
evolution.
life has never been observed to come from non-life. Ever. Second, to date, there is no known observable process by which new genetic information can be added to the genetic code of any organism. Without these,
Lord.
evolution's dead in the water. I mean, these aren't just side issues. These are imperative to evolutionary theory. If you can't get the evolutionary car started, you can't move it down the street. So, Professor, is there any new evidence you have to answer these 2 points?
Let me check the science journals.
She didn't teach them any genetics in this class at all. Like none, I guess.
Also, the new information argument, we have to start from, how do you define that? Please give me a definition before we proceed.
Yeah, but I guess in this class, this supposed science class in which they talk about biology and evolution, but not genetics, I guess. Somehow. Because otherwise, why would he say that, you know?
It's very interesting, kind of like how the hypothetical curriculum of this like imaginary classroom takes place, because it's wild. God, so where do we want to start with the claim here? With the claims they made here?
Well, I mean, I guess just with regard to because you wanted to come and talk about abiogenesis, so just with regard to his claim about no new genetic, no genes or whatever, duplication, transposition, insertions, right? Point mutations. These are all things that
that's a very interesting claim, because like anybody who's like in a college sophomore like bio lab can disprove that.
Yeah,
because you can actively see like events like pertaining to things like gene duplication and stuff like that, where like if what you're referring to is like genetic information as just being like the number of genetic characters in a in an organism, then a duplication is necessarily a gain of information.
Right.
But of course, they will have a very nebulous definition that is never clear. That's the
well,
problem.
that also just happens to reflect like the nature of biology itself, though, right? Like, kind of like how we were talking about complexity the other time. Information isn't really a well-defined term in biology.
True.
Well, you can root it in entropy. You can root it in entropy, right?
Yeah,
Entropy
but that's
right.
But that's information with respect to like some chemical reaction in that case, right? Like you could also talk about, like for chemical systems, you could talk about the information as it pertains to like bond angles between different atoms and what have you and what have you and what have you. So like you could refer to the amount of information as just being like how many nucleotides you know, are in the genome of an organism. You could just as easily, though, right, refine that to say, okay, well, maybe it includes something to do with like different mechanisms, like epigenetic mechanisms that pertain to this DNA. You know, or, you know, the way the DNA is organized and is expressed within the organism. And you can just keep going on and on and on with different ways in which you could contrive information. And each of them are to some extent valid. So just this kind of throwaway line that like, oh, there's no need for like, or that no new information is added. It's just it's unless you're like defining what exactly information means in that context, it's not really useful.
Right.
And the other important thing to really recognize about that as well is like this kind of hints at the point that creationists like making, but don't always like state it, and it wasn't stated here. But they think that like for evolution to occur, you always have to have gains of information. But I'm unfamiliar like with anywhere in the literature like where it makes that kind of point, like where it's a requirement of evolutionary theory to gain information. Like even if you lose, like even if there like that was true and all you did was lose information, you could get diversity within those life forms by the way the information is expressed.
So
right?
One thing they like to say is like when you point out that like, well, the definition of evolution is like a change in allele frequencies in a population over generations, right? That says nothing about more or less information at all, nothing.
Right.
And so when you point that out and you say like, well, a parasite or, you know, a once free living species specializing as a parasite, like on a bird or a mammal or something, you know, it's gaining information in a sense relevant to certain genes, right? It may be jettisoning other genes and structures and things, but some genes are becoming it's evolving those, or they're undergoing natural selection to become super good at a certain set of jobs, way better than their closest relative. And you point that out and you're like, well, that's evolution, right? It's undergoing morphological and genetic change as it specializes on this particular niche. And creationists really just respond, no. They're like, no, it's not gaining things.
You have to go
structures.
to human, the pinnacle of creation. Yeah, you have to go to human.
Yeah, they're like, it's just losing stuff. This leech has lost its ability to live freely. And so once Dapper and I like made the joke that you could describe all of evolution as a series of losses, right? You know, you go from like the transition from like, you know, fish to amphibians. You could describe that as just losses, right? Well, okay, we lost the ability to breathe underwater. We lost our fins. We, you know, all that sort of stuff. And so like it's a completely nonsensical argument. But
yeah,
it's always the moving goalpost.
Like for example, if you go from a protein that does a reaction, catalyzes reaction A and B, and then you have a mutation where it becomes better at A but loses B, and there's a lot of function. But then you go in the opposite direction, and then you say, oh, you lost specificity.
Right.
Right.
Yeah, it's always something. It's always heads I win, tails you lose. There's never a way. It's like you said earlier, Immutable. They will never give you a specific prediction because if they do, you can potentially prove them wrong, and then they look very silly.
And you can using the Bible. The last thing this guy said, we have never seen life come from non-life. Well, last I checked, water isn't alive. And yet, the Bible claims that birds were created from water. So
yeah. So I mean, even if you like don't pick on like they're being inconsistent with how Scripture is read, there is a paper I would like recommend. That's kind of a nice little paper. It's easy to read. I'm posting it in the private chat.
Okay.
If you guys want to, want to pull it up or read it at some point or whatever. But the long and short of the story, like that this paper is kind of trying to tell, and it's related to abiogenesis, but it's kind of making the point that like what exactly life is, right, is kind of like akin more to a philosophical question than it is one that's empirical.
Right.
Because while there are certain things you can definitely say living things do, right? Those things are best understood in terms of processes rather than just being on a checklist of like, oh, this thing is alive, this thing does not. Like this thing is not, right?
By the way,
And it's kind of like the same.
I put the link in the public chat as well for people who want to check it out.
Thanks, Peter.
Yeah, there's like good questions. Oh, go ahead, Nestle. Sorry.
I said I don't interrupt you. Go ahead, you finish, and then I will.
All right. No, go ahead. You're fine.
Oh, all right. Like what I was want to say is that the definition of life, I always remind of like one of my favorite persons in the origin of life research is like Eric Smith, and he makes the point that if you look at individuals and you treat life as a property of individuals, like life is a predicate of a noun, then the question doesn't really make sense whether a thing or an individual is alive or dead, because you get many different paradoxes, like is a mule alive or is a virus alive or not?
Yeah.
So it's,
and I mean,
so it's
yeah.
Yeah. You want to say like a go ahead.
To kind of add on to that point, right? Like that's been a raging conversation in like biological circles for like to the point of viruses, right? That's been a huge point of controversy, like in biological communities, as to like whether you should actually classify like life or viruses as a form of life, right?
Yeah.
And it's because. Go ahead.
Oh, so again, I don't want to interrupt you if you want to make your point then.
No, you're fine. It's
all right. But that Eric Smith is pointing out that he makes the analogy that if you look at a single water molecule and you say, is it a water molecule, a vapor, or a liquid? You cannot tell it from just the water molecule in isolation. A liquid and a vapor is a relational thing between many different water molecules, basically. And he takes a approach on life as by saying like, oh, if instead of looking at individuals, let's look at the ecosystem or the biosphere as a whole, and let's view it. What is the most consistent feature of the biosphere? And for the entire history of the Earth, of the biosphere, the single thing that is most consistent about it is the core of biochemistry, especially the intermediates of the citric acid cycle. That pathway, that small network of small organic molecules, that's a state the most consistent thing on the entire biosphere, and it's not individuals. The property is not carried by individuals itself. It's just the property of the whole biosphere, and that's in his definition of life, or his provisional definition of life, is the participation in the biosphere. And by that definition, it's a lot more easier to think about what life is as a larger scale property instead of just looking at the individuals alone. Just like with individual water molecules, you look at the whole phase of the water itself.
Yeah, I mean, I think it's been a little bit of time since I read the paper fully. I think what the paper is trying to say is like it might agree with that view. But I think it's also trying to make the point that like to understand what life is to kind of like understand like the more general qualities of the things life does, right? And not being so like stringent on like the way in which we define life as being like so related to the history and development of Earth, like necessarily, right? I mean, so like
go ahead. Sorry.
Go ahead.
No, go. I'm not trying to interrupt. Sorry. Go ahead.
Like the reason the paper kind of takes that view is like there's going to be like potentially like the discovery of life on things like Europa or like other moons, which seem to have like compounds that are related to like the activity of certain biological life and things like that, and that don't seem to really be very simple to form, like given like what we understand about certain types of chemistry that occur with planets. So like it could be that the kind of life we discover on other planets is very different from the kind of life we have, but it also might be very similar. And so like I think it mentions like three major things. Like two among them though are kind of like this ability of life to like to harness and manipulate energy from, like to kind of create a distinction between like the exterior environment and the like in the interior environment of the protocell or cell itself, right? So it's kind of like separation and manipulation and harnessing of energy from these two from these two different things. And also like another one is like the ability to like sustain and undergo self-replication, which is related to the idea of like autocatalysis.
I believe. Oh, so sorry.
Oh, go ahead. Autocatalysis is usually a word that will bring up interesting debates with people.
Yeah. I just want to point out that this paper that actually makes the same point that I was just making. Like it's, if I can quote one section, it says, "We take this moment to emphasize that our definition of life applies at the system level. The pillars that can be ascribed to a certain system depend specifically on the boundaries with which we use to refer to that system. For example, which pillars do viruses perform. A single virus in isolation cannot perform any of the pillars. Viruses in a system consisting of viruses, bacteria, and nutrients that can perform autocatalysis, there's that word again, and through the coercion of their bacteria host dissipation. Viruses in a biosphere that is co-evolving with its environment will cause not only autocatalysis and dissipation, but learning through evolution as well. In certain ecosystems, viruses may even have important homeostatic attributes to the system by introducing auxiliary metabolitic genes to their host and recycling organic matter. Thus, the argument about whether a virus or a mule is alive becomes irrelevant under the assumption that liveness does not emerge at the molecular, cellular, or organismal level. Like others have suggested, we contend that the living state is maybe best assessed at the ecosystem or planetary scale. So basically the same point that I was previously making. And also one of the citations they provide in this section is also Eric Smith, the one that I was previously referring to. Yeah.
Good to know.
So Eric Smith and also Harold Morowitz, they are the people who contend that life as a property or is not defined at the individual level. Like if you ask whether an individual, like a virus or an organism, is alive or not, it's a category error, basically. A category error.
I mean, not to take it off topic, but I mean, I think it's a similar issue to the kind of like the problem of consciousness, right? This idea of like this general principle of like you can have all the neurological activity and correlation you want to, right? But like it doesn't seem necessarily that like that just using that kind of data of like neurological like descriptions that you would necessarily have to conclude that a certain agent is conscious or something like that, right? It's just like very sophisticated like biochemical activity that's occurring.
Oh, Peter, can you take down the video and go back to the four of us?
Well, that depends. If Jackson wants to make this a long story short, or if he wants to go to a new chapter.
A new chapter. What do you mean?
See, the way I put it, that's confusing, right? Well, we do have another video that we go to, or we can make a long story short and cut it here. Oh, the one you just.
You're so funny.
See, I knew that if I were to put it like this, that it would be confusing. So if
we'll do the long story short one next time.
If we can,
we can just discuss Abiogenesis between the four of us. It would be fun, I think, too.
I don't know a whole lot about that topic.
Well, I mean, it's
nor do I.
Nor does anybody else really, if we're assessing the state of literature.
I mean, I've read very little.
Wait. So immutable. Are you saying we're clueless? Sorry, Jackson.
No, that's just we're definitely not clueless, but I mean we have like different disciplines like within Origin of Life that are trying to address the problem in their own kind of style and flavor, that it kind of doesn't even seem like that some of the research you would expect origin of life to address is being addressed, like with certain groups that are doing it.
Like we also discussed it last week off air about like you have often like two main camps, quote unquote, like the metabolism first camp and the genetics first camp, often called that way. Yeah.
Mm-hmm.
And I tend to gravitate towards the metabolism first. That's just me, because I often read the literature by those who maintain that view, like Nick Lane and Eric Smith in particular. Those are like one of my favorite people to go to. Yeah. Of course, I have seen like John Sutherland talks. Like he gives really good talks on like the how you like he did very interesting talks about how transfer RNA might have originated and how the genetic code emerges from the like the structure of the transfer RNA even. Like there's a correlation.
His most recent article, if I'm recalling right, or one of his more recent articles, is proposing transfer RNA as one of the mechanisms in which you can get symmetry breaking in like regarding like the chirality of peptides that form.
Mm-hmm.
And he's using that using something to do with like electron spin. I can't remember its name now.
The most recent thing on abiogenesis that I read was a book. Was Jeremy England's book, "Every Life Is on Fire." Not very good. Don't recommend it.
Really? Oh.
He talks he talks almost not at all about abiogenesis. Almost not at all. Yeah.
Oh, I actually that's actually one of my books I want to read. So
yeah, I thought it might be good because I recognized his name and I was like, oh, okay. And it even says like, on the dust jacket or whatever, it's like, oh, discusses.
What was his most talked about topic that he addresses in that book? Or like, what does it mainly talk about then? Instead of
so his bit is like, what do you call it? It's like the molecules that can dissipate energy. They like become progressively better at dissipating energy. He like very vaguely mentions it towards the end. He doesn't give you really any specifics about it. He's just like, oh yeah, we take some molecules and we do this, and this is kind of the result. Dissipative adaptation, that's what it's called. He just kind of mentions it, and is like, yeah, and that's it. And it's like
it's a very purely physics perspective. Like it doesn't mention like what the molecules are doing or the pathways or whether you get specific RNAs or something. Like maybe you don't get that from his book. No,
I actually told Inspiring Philosophy after I read it, I was like, you do better just reading his normal papers rather than the book. It's not very good. Sorry, but it's not like Nick Lane's book where it's like just the facts, right?
Nick Lane has a good way of writing. Like he's a very good writer, I would say. Yeah. Like I've read like Eric Smith's book, but it's a very arduous and very detailed to go through the Eric Smith. But Nick Lane is a very good for like layman to and also very poetic style of writing too. Like he's a good storyteller, Nick Lane.
Yeah, I expected it would be about like it would just kind of explain like dissipative adaptation and how it relates to abiogenesis, but it really doesn't. He kind of mentions dissipative adaptation, and that's really more towards the end of the book. So it's
interesting.
It's not very good.
Also funny. It's also funny because like I believe Jeremy Smith Jeremy England. Sorry, Jeremy England is also more in favor of the RNA first instead of metabolism first. I would think. I'm not sure.
Yeah, I think that's right.
Yeah, I mean, to me, it's also ironic because the metabolism first takes thermodynamics more into account, and at least to my opinion.
Right. Yeah. You're right. That is kind of ironic. Yeah.
I mean, it's also the point that like thermodynamics can develop later if it need like. Thermodynamics could be brought about as you have something which is capable of self-replication right? And sustaining it.
I don't agree. Like the thermodynamic, like even life today, like that life doesn't depend on like organic molecules from meteorites or even organic molecules from like lightning. It only depends on redox disequilibrium. If it also, of course, the carbon dioxide and the basic inorganic precursors like nitrogen, of course, too. If you have those, then life can consist. But without the disequilibrium, without the thermodynamic drive, you have no life. No.
Well, that's I don't think that's necessarily follows. Like the point, like the point of like the Murchison meteorite and things like that, is exactly the point that these processes, like you can get almost all, or like a very large fraction of like biosignificant molecules forming within meteorites, right? That have nothing to do like with traditional chemistry, in part because all you have with a comet is UV light, right?
Right.
Like that's one of the only means you can get like reactions to occur, and it still manages to form things like nucleotides and carboxylic acids and amino acids.
In outer space, you have extremely high activation energies from like UV and even gamma radiation. And at the same time, we also have very cold, extremely cold background temperatures. And in that condition, you can build up extremely complex molecules, but and also maintain them without them breaking down because of the extreme cold temperatures too. And that's why you can get these many different molecules, but most of them are also very different from what we see in life, but not all of them. There is some overlap, like I mentioned, like they includes like amino acids and some nucleotides as well. And if you go down into the planet, you get in the atmosphere. You can also have some high activation energies and also some, but not as cold as outer space. And you still get some familiar chemistry there too, with interaction between carbon dioxide and nitrogen, especially with lightning. Of course, the classical Miller experiment where you have the interaction with the atmosphere and lightning. You can also get some overlap with the chemistry. But when you go down deep into the geochemistry, that's when the chemistry of organic chemistry becomes so similar to life. You can almost see that in the proteins that life uses to, especially at the core of biochemistry, with the citric acid cycle and such.
Right.
Where they use the metal centers, it almost seems like the metal centers are just grabbed from minerals and just enfolded into the proteins themselves.
Well, right, because you get like pyrite and greigite and McKenna-white and chalcopyrite, which all have like variations on iron sulfide, and so these are like allowing electrons to be shuttled between molecules, and so these allow the formation or the like the transition from like carboxylic acid to amino acid and things like that. So I was actually looking at a paper that was discussing that the other day, because also, where do you find all those? At hydrothermal vents,
right. And also, like the reason why we often see some like even in very different circumstances, like in outer space with very high activation energy and very cold background temperatures, and then moving down in the atmosphere and down to the vent world. The reason why we see some overlap in the chemistry, not everything is the same, but there's still some very peculiar overlap. The reason because is, like as Eric Smith contends, is in biochemistry you have paths of least resistance when it comes to the interaction between the carbon dioxide and the many different relevant elements. So some of the molecules are more easier to make, even in under very different circumstances, and that's why you have these overlap between the very different situations.
Exactly.
Yeah.
So we solved the abiogenesis. There you go. Good job.
No,
I mean, I think. Oops. Yeah, I mean, I think the point of like making the point I'm making is just to say, look, you don't need hydrothermal vents necessarily to get some of these compounds, right? There's other
absolutely.
Like there's other ways. Like Sutherland's famous thing is like he's shown at least two different systems, like both this kind of chemistry he calls like cyanosulfidic chemistry or this kind of like chemistry using cyanide, derivative molecules, and also like with sulfur dioxide, SO2, where if you expose it to like UV light and a few other things that are periodically relevant, you get nucleotides, you get lipids, and you get and you also get things like amino acids that form out of it too, right? And in those kind of situations, like with shallow ponds and stuff like that, the Earth really doesn't have like a biosphere or an ozone layer, so there's constant UV radiation, and you have the benefit of things like wet-dry cycling that are occurring. And it's I would say, like, in that, like, to what I understand, it's not like just like that point alone is sufficient to say, look, I don't think like metabolism first is necessarily exclusionary to like other views like that are being played out like with abiogenesis research.
I'm a dirty pluralist. It's probably that a bunch of these processes were all occurring simultaneously.
I think so too. I mean, I don't think there's any contradiction like with each of them being viable in some sense.
Yeah, absolutely.
Well, I don't think I share that same view. I would say, like, we have some of the process on the the dry Earth with the wet dry cycling probably, but I don't see any particular relevance when it comes to life. It doesn't remind me of a lot of what's happening with the biochemistry that we do observe in us, basically. Yeah.
Right. I mean, I just think that's making a very strong and very possibly unjustified assumption, which is that what exactly necessitates that the chemistry like utilized like in early Earth has to be similar to that of the biochemistry that we currently see within life, right? I mean, I think that's it may be a reasonable assumption to some degree, but I don't know like to what extent it can be justified.
Well, if I can make one, maybe not a slam dunk argument, but just one argument in favor of that thing, is that when we see life from a thermodynamic point of view, we see that life is a dissipative system. It takes a disequilibrium of energy in the environment and then allows it to become more, basically increasing the entropy of the universe, right? It allows the dissipation of that energy from this equilibrium. And the particular disequilibrium is the redox chemistry. It's also important to point out at on Earth without life, what you get is that the Earth becomes a giant battery. When you in the interior of the Earth, you have more electrons. It can be donated, and then on the outer shell of the Earth and in the atmosphere, you have the interaction between the sunlight or starlight in general, where it interacts with water, and the water splits into hydrogen and oxygen, and the hydrogen escapes the Earth because it's a very light element, and oxygen stays behind. So that makes the atmosphere mildly oxidizing. So what you get is an Earth. It becomes a giant battery with one side accepting electrons and one side donating electrons. And that energetic stress becomes concentrated at the point where new rock meets water and at hydrothermal vents. That's where the stress builds up immensely, basically. And when you get stress, eventually something breaks. Often, like even when it comes to, for example, one example that Eric Schmidt often uses is lightning. You have in the atmosphere a high, I think a positive charge or maybe a high negative charge. I'm not sure about the details, but again, the charge difference between the ground and the cloud is very high. But there is not an easy way for that charge difference to be resolved unless the atmosphere becomes a plasma. And eventually, when the stress builds up so much, you get a breaking point where the atmosphere breaks into a plasma, and it allows a channel to the energy flow. And then basically the same thing happens at the point where a new rock interacts with water to release that stress in redox chemistry. And what I mentioned about the path of least resistance through organic chemistry allows this stress to be released. the dissipative system of life.
I mean, to go to a very to ask a very
one last sentence, and that gives life almost a necessity instead of an accident. It's basically a ball rolling down the hill. It becomes necessary to release this stress, basically. Yes.
It's interesting. Okay.
But so, I mean, okay, like one question, and I think me and you would both agree on this. Like any system that's capable of undergoing and that forms an autocatalytic set is going to form dissipative structures, right?
Okay, also, can you repeat that one time?
So, like, any ensemble of chemical systems which are themselves capable of autocatalysis are going to form dissipative structures by necessity, right?
Well, yeah, of course, it depends on what type of disequilibrium you're talking about. But yeah, when it comes to, for example, the specific stress that I was talking about, was like the interaction between hydrogen, like H2, and carbon dioxide. And when you let them interact, or when you allow them to interact, they will form water, H2O, and methane, CH4. And that interaction releases energy. But the problem is hydrogen and carbon dioxide doesn't easily interact to form that, to react and form water and methane. And what life does is it provides the easiest way for those two to interact and release the energy, basically. And of course, the most optimum thing in biochemistry is, for example, the citric acid cycle, where you have the autocatalytic cycle of the reverse citric acid cycle, as you mentioned before. Yeah.
Yeah, I mean, I think the other thing too is like, I don't know, maybe they do address this point, but I'm not aware of it. But like, if you're familiar at all kind of like with the regulation that goes into like different metals in their chemistry in cells, I mean, it's insane.
Yeah, it's insane, yeah.
Like it seemed like you need to have things like that will let you form peripherin rings and like these other things like where the chemistry that goes into like coordinating and kind of like maintaining redox states is wildly complicated.
Yeah, actually, the funny thing is that if I may not be I think I'm accurate about this. I need to recheck it, but there is one biochemical pathway that some forms of life use. It's called the acetyl-CoA pathway, and it's like you have several different pathways that fixes carbon dioxide. Like you have the Calvin cycle in plants, cyanobacteria. You've also the reverse citric acid cycle, as I mentioned before. But the acetyl-CoA pathway is the only pathway that fixes carbon and also releases energy. So there are some organisms where the pathway that builds biomass and gets energy is one and the same thing.
Yeah, and I think
and one thing that I want to mention is that those organisms don't depend on heme, I think, if I'm not mistaken.
Yeah, I mean, heme is one of your issues. I mean, but you have
but these organisms don't depend on that. They use the ferredoxins as the electron donor.
Right. I think the issue still kind of stands though, right? Like the major difference between, if I'm recalling right, like with the structural biochemistry of like things like heme or like peripherin rings versus like ferredoxins is the kind of modifications that occur like to this overall like motif of a porphyrin ring, right? And I think that like the point kind of stands that like for a lot of the chemistry that occurs within like biochemistry, any kind of chemistry that involves coordination of metals can very, very, very easily go wrong if you don't have systems in place which are able to kind of regulate the activity and coordination and oxidation and reduction states of those metals themselves, right?
Well,
and I don't think, and the last point is that I don't think when you're talking about the first kind of like life forms that exist, right, that they necessarily have that level of sophistication and complexity, right, to coordinate that, right, without having first like a pre-existing genetic system which is stable enough to kind of capture information, right, and kind of embed the structure of those, primitive proteins.
Well, I would say that, like, as I mentioned before about the biochemistry, about the path of least resistance to the biochemistry already gives you some of the information where it's self-maintaining to a degree. Of course, not as sophisticated as when it becomes under control and direction of proteins, of course, but still, it provides a groundwork where you can build up things to become more complex, I would say.
Well, I mean, it's not the regularities you have to be concerned with in this case, right? It's the cases in which, chemicals like that are involved even in protocell, right? If there's an interaction that occurs that like generates a free radical or something like that, that's going to wreak havoc on a protocell, right? That's very easily going to cause.
But you propose wet dry cycling exposed to UV radiation. Like free radicals is a very big issue when it comes to that.
Well, sure. I mean, I think the way that's overcome though is like, what does wet dry cycling do? It favors the formation of certain compounds, right, based upon the environment and also based upon the environment in which that wet dry cycling is occurring. Right? So, I mean, certain species may be sequestered very easily, right, based upon an environment that's aqueous rather than, a dry environment. And it could be the case that as this kind of process keeps occurring, right, you have mechanisms whereby these cells are better able to kind of deal with the formation of free radicals, or that the preponderance of different kinds of lipids are more stable to dealing with, damage caused by free radicals.
The problem is like the mechanisms that life uses to deal with free radicals and high intensity light. That is even more complex than the thing you mentioned about the controlling the metal centers and such.
Well, sure, but I mean, even then, it's still the same issue, though, right? Like the vast majority, if not all, polymerases, right, use either magnesium. If I believe it's magnesium, right, that the polymerases use as part of the core for metabolic activity, right? So while that might be true,
when it comes to polymerization of nucleotides, I think magnesium is I think so. But when it comes to these like the core of for example, the citric acid cycle or many related reactions, I think there are some research that suggests that you can do a lot with iron ions. You can do a lot of that with that,
Yeah, iron can be problematic. But to your point about genetics, it's to the point about like genetics and the mutation there, it's somewhat ad hoc in the sense that genetics is going to be like a stable form of self-replication, right? Especially one that is preserving genes, right? Is going to be a very late development in the origin of life, right? Like the transition from like DNA to RNA or from RNA to DNA, and the means by which once you have like a stable genetic code and the kind of minimalistic structure for the cell to keep on going, that's going to be one of the last things that potentially evolves, right? So at that point in time, you probably have things that are able to some degree or another deal with issues like coordination chemistry and things like generation of free radicals and stuff like that. At least the way I'm seeing things.
Well, it's just also like I can like look at the current life, and I see that there are some some very simple organisms that I mentioned about the ones that use the acetyl-CoA pathway, which are often associated with hydrothermal vents, and those really hate oxygen and the free radicals that are often associated with oxygen. So it seems to be that life learned to deal with oxygen and also to learn to deal with high intensity photons, and also of course some of them learned to harness the energy of photons for photosynthesis as well. That came later in my view.
Yeah, probably. And it's not to say you can't have life develop like within a wet dry system, like where it's developing in regions that are anoxic, right? Like soils that are very non-permissive to the presence of water, to the presence of water.
Well, again, I then I would with that, and I would fall back again on the thermodynamic argument that I used before. Like in the vent world, building a biomass is a ball rolling down the hill. But when you are talking about the wet-dry cycles and UV radiation, you talk about like a Sisyphean task of pushing a ball uphill, and then it will continue rolling down the hill again and again. Basically, it doesn't seem very plausible to me in that environment.
I mean, it's just the case that like in certain environments, certain compounds are favored to form, and while that environment is in place, right, they're able to form in sufficient quantity. And once that condition is changed, other molecules that are, form in a different kind of environment will form in that environment and accumulate in a similar way. And there's mechanisms which will preserve, certain classes of molecules, right, to a certain degree. And you're going to have interactions between those different kinds of things. Like even with,
it's also true for the vent world. Like when you get the ball rolling, and for example, an autocatalytic cycle, you have a self-maintaining system at every transition. Like it's often like you're familiar with phase transitions, right?
Yeah.
Immutable.
Yeah.
Yeah. You feel like and one of the things that like Eric Smith talks about is that the origins of life involved a series of phase transitions, and one of the first was the phase transition in organic chemistry, where you have an organized biochemical network, and then later on you have the phase transition from just to summarize, from that network you can build up things like cofactors, which can feed back onto the core metabolism by increasing the reactivity. And then from the cofactors, it's interesting that when you look at the cofactors, they often seem like they are trying, quote unquote, to be polymers. Like, for example, you have NADH, the cofactor NADH. There are two nucleotides involved, Yeah. And also, the nucleotides, the way the nucleotides are bonded with each other is not the way how they are bonded in RNA or DNA. Like, it's a very different bonding. Like, it's felt of course, there's no thing as failure in chemistry, but anyway, it's all like from the perspective of polymers, it's almost like it's failed to polymerize correctly, but still you get a functional cofactor that way. And also one of the nucleotides in NAD is adenosine, but the other nucleotide is one that is not used in RNA or DNA. There are many different nucleobases in biochemistry, but only a subset of them are used to build polymers like RNA and DNA. So it seems to be that there is a reduction of the degrees of freedom when you move from the cofactor phase to the polymer phase, and that reduction in the degrees of freedom seems to be a phase transition. And that's one of the arguments that they use in the book, a phase transition from one stage to the next.
Yeah, I mean, I'd have to look more into it. I mean, I think even in the case like where you look at metabolic cycles like the citric acid cycle and things like that, even with certain reactions, right, you still need, in certain cases, like the involvement, like the donation, quote unquote, of an ATP molecule to kind of keep things going, because certain processes within the generation or like the process of the citric acid cycle, you get a reaction or so that's not thermodynamically favorable, and so you have to have a GTP or an ATP molecule that gets hydrolyzed to kind of keep pushing the molecule back through the cycle.
Well, in I think it's in certain environments it isn't the case to. I'm not sure entirely. Like maybe it's also the case in anoxic environment. But I'm pretty sure like I think that they showed it in one paper when you have in anoxic environment without oxygen, and the building up of biomass is thermodynamically favorable. So that's why the citric acid cycle goes in one direction, because in one direction it's like with oxygen in us, our citric acid cycle goes one way because breaking things down or breaking organic molecules down to CO2 is favorable with oxygen, but then in anoxic environments, then it becomes favorable to go in the opposite direction. And so maybe you don't need ATP necessarily to do that.
Yeah, I think I'm talking about the forward citric acid cycle.
The forward citric acid that came later. The forward citric acid cycle was that came about after oxygen came more prevalent in the atmosphere, because at that point it became sensible to get energy from organic molecules. Yeah.
All right, so we're gonna wrap this up because we're approaching the 2-hour mark.
We can keep going.
It came so.
Well, I
the
am
conversation
enjoying
was
listening.
really enjoyable. Yeah.
I'm enjoying listening to it, certainly. It was a lot less screamy than other conversations about Abiogenesis recently. I'm not going to say which ones.
You can't do this chemistry immutable. You can't. You just
I know. Just impossible.
Yeah.
True. So what is going on
Jackson,
everyone's channel in the near future?
Jackson, can you write it out on the blackboard for me?
No. No blackboards or whiteboards.
Nope, can't do. Just clueless about it.
Yeah.
Clueless.
So what's going on you guys' channels in the near future?
Well, I've got a blast from the past. Oh, and you know this guy. 4 years ago.
Do I?
Yes. 4 years ago. This was before video even existed. Keep in mind. You had a conversation with a guy from Texas called Glenn Coker. You recall the guy? He was an amicable guy, but he was young Earth creationist, and you had a conversation on my channel with him about whether or not evolution is true. And so he recently.
I think I've slept since then.
Yeah. So he. You all know Frustrated Atheist, I guess. Phil.
Yeah.
Yeah.
I think so. Yeah.
So Russ was my co-host for the first show that I did with him, and that ended up being so good that the two were planning to hook up and have a drink together. But he recently started commenting on my channel again, saying that he wanted to have another chat. I'm in the process of setting that up, and because of there's change on Arn's schedule, I had to postpone my show for today because Arn could get a day where we all could join, so we had to do this today. But the fun fact is, we're going to have 2 Bible studies a week during this, at least during the summer. That's going to be and
that does sound like fun.
We're going to get a special show on slavery in the Bible, whether or not.
Yeah.
Oh boy.
Ooh, fun.
Oh, God, that's just, man. Talk about beating a dead horse.
I think.
So if you're going to do a show,
the guy who runs point on that.
Yeah, if you read the Bible and you invite a young Earth creationist, it's going to be an issue, or not. Or slavery in the Bible.
Oh yeah.
I think Arn really wants to hammer this out.
It's not real slavery, Peter.
No, it's
not real slavery. The people consented to it, don't you know?
Yeah.
Oh, really?
Slavery plus.
You can beat them and pretty much kill them. Not a big problem.
Well, but even if it was slavery, it was the best form of slavery we've ever had ever.
Right, exactly.
Yeah, and we're all slaves to Jesus according to the Bible. So
I was reading.
We're all
books,
slaves to our jobs.
One of the books I'm reading talks about the argument that like some people put forth that like taxation is slavery, and he says, "Oh, really? Taxation is slavery? So you'd rather work my fields than pay taxes? Okay, that can be arranged. No, why not? I thought you said they were the same thing.
Yeah.
So." But anyway, okay.
Yeah, so that's going to happen. So this Saturday, there's not a Blasphemers Bible. That's going to be, I think, next Tuesday. We still need to hammer out whether it's going to be Wednesday or Tuesday. But we will be here for reading Joseph Smith Sunday on Orange Channel.
Mm.
Checking out probably the most valid holy book on the planet, the Book of Mormon.
Is it the
there we
most
go.
valid? What about you guys, Nestle? Immutable? You guys got anything coming up?
I'm still intending to do a video series on evolution of photosynthesis, but of course it's going to be a long process still. Yeah.
Yeah. Okay. Immutable? You plan on doing anything in the near future?
No, unfortunately, this summer I'm going to be neck deep with other things. So,
oh boy,
maybe one of these days, but just when life gets simpler, perhaps we'll see.
Okay.
We all evolve to be amoeba. Maybe life gets simpler.
Yeah, see, there we go. See, if I was just as simple as an amoeba, and what a dream that would be.
I mean, immutable, it's easy enough to do. You just have to evolve, because you're going to lose more and more functions, and then
I know. I just had to evolve backwards. See,
around.
I just have to change. I just have to tell the evolution fairy to just to just turn directions, and it'll do it.
Very true. On this channel, we've got the salamander's tail coming up next, because we just did the elephant bird's tail. So now we're leaving the amniotes and moving on to the amphibians. So yay, the last of our tetrapod kin.
Oh, how is your
video for? Oh, so it's only one video for the amphibians, or?
No, there's I think 3 of them. It's it's like Ensatina salamander, narrowmouth toad, and axolotl, I think. What were you saying, Immutable?
All right.
How are your and RJ's project on the rocks where they're coming along?
The second volume, it is coming. It is certainly coming. I don't know. I have no
no idea when
for when it will be out, but I have been working on the on one of the chapters just this past week. So yeah,
nice.
I'm also very busy with a lot of things, but I'm working on it. So yep.
Fun.
Yeah, that's true. I was actually just looking through. I was flipping through volume 1 just the other day. And yeah, it honestly surprises me how much stuff we covered in that book sometimes.
I still have not gotten my hands on a copy of the book, so I will also put that on my to-do list.
Do it.
I have a copy, but my copy's in Canada for some reason, and still.
Oh wow!
Then it needs to be shipped to Jackson, and from Jackson it needs to be shipped to.
My dogs are barking at something. So all right, well we're gonna call it. So thank you everybody for watching. Thanks everybody in the live chat. Thank you guys for being here. Really appreciate it. And we will catch all of you next week. So bye everybody.
Bye.